So let's go ahead and take a look at example 1. Number 1 says 2x plus 3y equals 6 and 4x minus 3y equals 12. So if we take a look at step 1, it says to line up the terms in the first and second equation, and they can be in any order. Well, as you can see, we have the x terms lined up here, the y terms lined up here, and then these plain Jane numbers out here at the end. So that's good. That's what the direction says. And as you can see, looking at the questions in the notes today, other than question number 4, that's already all done for us. All right, step 2 says we're supposed to manipulate one or both equations, if necessary, so one set of terms is like in terms of value, but opposite in terms of signage. We'll take a look at this y set of terms here. Both of these happen to say 3y, but one of them has plus in front of it, and one of them has minus in front of it. So step 2 also happens to be done for us already. All right, so once we've done that, what the directions say now in step 3 is we're going to add these guys vertically. We're going to add each element vertically. So we're going to add the x elements and find a solution, add the y elements and find a solution, add the 6 and 12 and find a solution. Now, there's a reason this is called the canceling out method or the elimination method here. When I have this plus 3y and minus 3y and I add those up, those guys are going to disappear. And that's what's going to happen in every single problem once you set it up right. Something is always going to disappear. That's the elimination part. So I don't need to write 0y there when I do that. That's just gone. I've got 2 x's and 4 x's, which goes together to make 6 x's. Again, I'm just adding this way. And then 6 and 12 goes together to make 18. So if 6x equals 18, what is x? Well, x has to equal 3, because 6 times 3 is 18. All right, and that takes care of now here what is step 3 and step 4. I added vertically, and then I solved what I had left for the variable. Now what you're going to do is what's going to look like substitution method. What you're going to do is you're going to pick one of the original equations, it doesn't matter which one, change x into 3, and solve for the other variable, which is y. Which equation you pick is up to you. Let's go ahead and pick this top one. 2x plus 3y equals 6, but we now know that x is 3, so I'm going to change x into 3. So this is 2 times 3 plus 3 times y equal to 6. Well, that's the same as 6 plus 3y's equal to 6. Well, now it's just solving an equation for y. We've been doing solving equations for a long time. Solving equations says variables on the left, got that, numbers to the right. Well, this 6 over here is a problem. That's a plain Jane number. It's supposed to be over here on the right side with this other 6 that's also a constant, a lonesome number. So let's do this how we solve equations. Opposite side, do the opposite. The rule we've been using forever. I'm knocking 6 off both sides. That makes this one go away, and it says 3y equals 0. Well, if it says 3y's equals 0, that means y has to equal 0. 3 times 0 is 0. So my solution to the system of equations here ends up being 3, 0. At 3, 0, if I graph these, that's the point at which the graphs would overlap. If I plug them into the equations, both equations at the same time, for x and y, that's that set of values that's going to make the left side equal the right side, again, in both equations. All right, let's try this again here with question number 2. Question number 2 says 2x minus 9y equals 7. And it says negative 2x minus 1y equals 3. Well, if we go through the steps, step 1 is handled. Step 1 again says line up our equations and the terms in the equations. X's are lined up, y's are lined up, plain Jane numbers are lined up. So this works. That's the only way you can do this. Step 2, we're going to have to manipulate the equations now. So one set of terms is like in terms of value, but opposite in terms of the signage. So look, these are both 2x. This guy's positive, and this guy's negative. So that's exactly what step 2 says, so that he already did that for us. So we can go to step 3 now, where I'm going to add these guys vertically. Now again, these two x values here, they're going to cancel each other out. That's why this is called the canceling out method or the elimination method. When I add those up, they go to 0. 2x's plus negative 2x's. So all I have to worry about is what's left. I've got negative 9y and negative 1y, which is negative 10y. 7 and 3, which makes 10. So I've got negative 10y's equals 10. Well, that means y would have to be negative 1. Why? Because negative 10 times negative 1 is how I make positive 10. All right, so now that I know y, I'm going to plug that into one of the equations for y and solve what's left for what will now be x. So as not to be creative, I'm going to go ahead and stick with that top equation. Okay. 2x minus 9y equals 7. And we now know that y is negative 1. So I'm going to change y into negative 1. So the middle part here, look, I've got minus 9 times negative 1. Well, as you can see, you have what looks like two negative signs there. If we kind of ignore that 2x in front, that's, of course, going to change to plus in the world of multiplication. This is 2x plus 9 equals 7. Solve the equation. Well, again, we're using the same rules for solving equations we've always used. Variables on the left, numbers on the right. So this 9's got to travel. So let's knock 9 off both sides. Again, when I move something to the opposite side of the equal sign, I do the opposite. So I've got 2x equals negative 2. 2 times what number is negative 2? We know that 2 times negative 1 is negative 2. So x has to equal negative 1. There's my x, there's my y. Write my solutions, negative 1, comma, negative 1. Again, same way we've been writing solutions when we graphed and did substitution, x, comma, y, the way we always write a point. Kind of hard to screw up here, though, since they're both negative 1. All right, let's go ahead and take a look at question number 3 here. Question number 3 says negative 3x plus 4y equals 5, and 3x plus 11y equals negative 20. So, as you can see, this question is set up just like the previous two. It's not till the next one that we're going to have to handle some of those initial steps. The x terms here are alike in terms of their values. They're both 3 in front, but opposite in terms of sign. This guy's negative, this guy's positive. Obviously, we've met the other check. The x's are lined up, the y's are lined up, the numbers are lined up. So let's start eliminating here. These two guys, again, those are the guys that are going to eliminate. I have negative 3x's, and I add 3x's, and that doesn't leave me any x's. So I just have to sum what's left. 4y plus 11y is 15y. Notice if it has a minus in front of it, I'm treating it like it's negative. Now that doesn't apply to this question, but it has applied to some of the other ones we've looked at. And then here I've got 5 and negative 20, which is negative 15. So 15y equals negative 15. That means y has to equal negative 1. Because 15 times negative 1 is negative 15. All right, so now I'm going to plug that value into one of my equations here for y and find what I will have left, which will be x. Let's be creative on this one. Pick the bottom equation. Again, you can pick any equation you want, just like with substitution. It doesn't really impact anything. Generally, if there was one that looked shorter, I would pick it. But that's not necessarily always the best. All right, so I'm changing y into negative 1. So this is 3x plus 11 times negative 1 equals negative 20. I've got 11 times negative 1 in the middle. That's negative 11. All right, so use our rules of solving equations now. Variables on the left, numbers on the right. So the only trouble we have here is this negative 11. I'm going to move that to the other side by adding 11 to both sides. Cancel those out, and that gives me 3x's equals negative 9. 3 times what number is negative 9? 3 times negative 3 is negative 9. So I have my x, I have my y, I have my solution because, again, it's just x comma y. Negative 3 comma negative 1. All right, now, number 4. Number 4 here is where we're really going to have to do a little bit more work. Because as you can see, looking at the notes ahead of me here while I get ready to write this up, in question number 4, the terms aren't even lined up. And worse yet, I don't have anything opposite in terms of value here, or even any matching variable terms here. I've got 2x minus 5y equals 6, and I've got x, that should be equals 2y minus 2. There's a double equal sign in there, but notice it does say negative 2 there because it should say minus 2. It should say x equals 2y minus 2. All right, so we have to manipulate this equation to somehow make it look like this one. I'm going to stick with writing the x thing first and the y thing second, and then the equal sign and then the number. It doesn't have to be that way, but that is what we call standard form that you've seen before, and that just seems to work out rather nicely, and it's really something we don't have to think about much. So that means this 2y has got to come back over to the other side of the equal sign. Remember, you're doing that just like you're solving an equation, but you're never really solving anything. So I'm going to knock 2y off both sides. That'll make this go away. My new equation here will say x minus 2y equals negative 2. All right, so let me consolidate here. The top equation, I haven't played with it all yet. It's just 2x minus 5y equals 6. Bottom equation, x minus 2y equals negative 2. So at least now they're lined up. But I don't have anything like in terms of value, but opposite in terms of the sign. As you can see, these guys here, if we look at the y's, they both have minuses in front of them, and they're 5 and 2, so that doesn't help me. Here I've got a 2x, and here I've got an x. Those aren't like in terms of value, and they're both positive. So here's what you do. Here's the trick to elimination. The one little rule that can save the day and not make us do substitution here. You're allowed to multiply either or both equations by any number you need to come up with what is kind of an equivalent expression there, an equivalent equation. Think of writing an equivalent fraction. It's the same idea. All right? You've got 2x minus 5y equals 6. You've got x minus 2y equals negative 2. You could, if you wanted to, multiply the whole top line by 2, which is me multiplying each element by 2. And I would end up with 4x minus 10y equals 12. You could use that now to eliminate. Right, you could multiply the whole top line by 5 and end up with 10x minus 25y equals 30. And you could use that to eliminate. Again, you can do this for either equation, and you can multiply either one by any number you want to make that happen. But remember, our goal here is to make one of these things, the x's or the y's, like in terms of the value, but opposite in terms of the sign. So let's just say that I decide to do that for x. Again, I'm just making a choice here. There's no magic here. There's no voodoo. It's just me picking something, and I happen to pick x. In order to meet the requirements for elimination, if this one says 2x, probably want this one to say negative 2x. Right? Well, what would I have to multiply this guy by to make it say negative 2? Well, since there's no number there, that's like a 1. So I would be multiplying by negative 2. So I'm going to multiply this whole line by negative 2 to make that happen. Now I'm still not doing anything to that top equation. So this top equation is still 2x minus 5y equals 6. Now, as far as me multiplying by negative 2 here, you just can't multiply this guy by negative 2 and say done. You have to multiply each element by negative 2. So you've got to take negative 2 through to the x, and negative 2 through to this 2y term, and negative 2 through to negative 2. That's the only way you can do it. Again, think of writing an equivalent fraction. If I multiply the denominator of a fraction by 7, I can't just multiply the bottom by 7 and say done. I have to multiply the top by 7 as well. It's the same thing here. I have to multiply everything by negative 2, not just one part. So I'm going to take this negative 2 through the x, negative 2x, take this negative 2 here through the 2y, but notice it's already got a minus here, so that's like two negatives. So that's actually going to change into plus 4y. Here I would have negative 2 times negative 2 is positive 4. All right, and after much work and much struggle, we're now ready to eliminate. Because as you can see, I have 2x and negative 2x's here. Those are going to cancel each other out. So I got negative 5y plus 4y's. That's negative 1y. 6 and 4 go together here to make 10. So if negative 1y equals 10, that means y has to equal negative 10. How do I know that? Because negative 1 times negative 10 makes positive 10. All right, so finally, again, after quite a bit of work, we found y. Now that I found y, what I'm going to do is plug it back into one of my equations here and find x. Now you've got a lot of choices here. You can plug it into one of the original two equations. You can plug it into one of these two that we've modified, or we can plug it into one of these two that we modified. It doesn't matter. Either way or any way, it's still going to work out that you're going to find a valid value of x. I see this equation here, though, this x equals 2y minus 2, and my mouth is just watering because it looks like a short equation. So let's go with x equals 2y minus 2. If x equals 2y minus 2, I'm changing y into negative 10. So I've got 2 times negative 10 minus 2. 2 times negative 10 is negative 20. Minus 2 is negative 22. So x is negative 22. And now I have my solution, negative 22, comma, negative 10. The values for x and y that satisfy both equations at the same time that make the left side equal the right side. Or if we were talking about graphing these, the point at which these two graphs would overlap is negative 22, comma, negative 10.